All right, today, folks, we're going to be working on long division of polynomials. If you recall way back to chapter 1, when we were doing factoring of cubics, the way you factor a cubic is you take the cube root of each term, and then you have to divide it into what you started with to get your other factor. And I warned you back then that we were going to eventually hit this day where we're doing long division of polynomials. It's just like long division of numbers, and that's the problem, okay? Because with the advent of calculators, it was so much easier back in grade school for your teacher to hand you a calculator to do a long division problem rather than to really adequately learn how to do long division. So that's what we're going to struggle on. It's not that the concept is difficult, it's because you're never really instructed to do it all that often. But we will get through it. All right, when you talk about long division, let's first look over here. This is a very typical long division problem with numbers. 32 will not go into 4 0 times. It just won't go. 0 times that is 0. Most of the time, you just skip that one. If 32 doesn't go into 4, you immediately go to 48. But for the process here, I wanted to show you all that. So 32 doesn't go into 4, so 0 times that is 0. You subtract, you get 48. 32 into 48 goes 1 time. 1 times 32 is 32. Subtract, you get 16, bring down your 7. 32 into 167 goes 5 times, and you take 5 times 32, 160, and you end up with a remainder of 7. Now, there's a couple different ways you can deal with your remainder. You could put a letter R and a 7 up there, or you could put 7 over the divisor. And there's 7/32 is a way to represent your remainder, okay? Now, when we get into polynomials, it's pretty much the same. The author in your homework likes to give you different ways you can write your division problem. And I want to walk you through that just to make sure everybody understands that. If the divisor is d of x, here's the divisor. If the dividend is p of x, here is the dividend. You're taking the divisor into the dividend. The quotient is your answer, q of x. The remainder is the 7, okay? Now, how do you check? Let's go back and talk about this problem. Suppose you get 15 with a remainder of 7. To check your work, that's going to take you back to about 5th or 6th grade also, because to check your work, you take 15 times 32, and we're going to take 15 times 32, which gives me 480. Then you add your remainder. So you take your answer, 15 times the divisor, 32, and you add your remainder, and you should get what you started with, the dividend of 487. That's the way to check your work. And then I'd already talked about putting the 7 over the 32 as a way to handle your remainder. So when you're dividing the 487 by the 32, you get your answer, q of x, and then you take the remainder of 7 and you put it over the divisor. So it's just 2 different ways you can write your division problem, okay? The check, and also a way to write it with your remainder as a fraction. Now, as far as doing long division of polynomials, this is pretty much going to take us back to chapter 1 again, all right? So here's an example that I found, and if you want to get started here, you say, how many x's are there in 2x squared? You don't have to look at this whole thing, okay? You can look at the first part. It's kind of like taking 23 into 874. If you don't know how many times 23 goes into 87, you can say, well, just to get started, how many times would 2 go into 8? It goes 4 times. And that would be a way to get started. Is 4 necessarily right? No, you'd have to check it. Is 4 times 23, I think, is too big. You might have to drop down to 3. But it's a way to get started. And that's what I'm doing here. How do I get x into 2x squared? Well, whatever I think it is, I would put it up there, and then I have to take that times both parts, okay? And I want to get a 2x squared. The 2x is needed to create the 2x squared. Whatever you put up there times x has got to give you 2x squared. Okay, so 2x times x is 2x squared. 2x times 2 is 4x. You draw the line and you subtract. And this is what causes more problems for people when they do long division. When you subtract polynomials, you have to take a negative into the second term. And I think it is very helpful to make your changes of signs like that. Now, a 2x squared and a negative 2x squared, they go away. A 7x and a negative 4x is 3x, and you bring down the next term. How many times does x go into 3x? It goes 3 times. Why is it 3? Because you need 3 times x to get you 3x. That's what you should be thinking of. What do I put up there to take times x to get that? So 3 times x is 3x, 3 times 2 is 6. When you subtract, you take the negative in. And I always write that with little parentheses to remind me that I've taken it in. These go away, and 6 minus 6 is 0. There is no remainder, and your final answer is simply 2x plus 3. Okay? All right. How about another problem? Okay? This is a big one, a trinomial into this polynomial. How many times will x squared go into x cubed? Once again, you have to think about, what do I put up there so that when I take it times x squared, I get x cubed? Well, it's going to be x. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 1 is x. Go in and change your signs. Okay? Change all your signs. This becomes a negative x, see it? This is a negative 12 and a positive 2 makes negative 10, and those go away. Bring down your 42. How many times does x squared go into this? Think of, what do I put up there to take times x squared to get that? It's a negative 10, and you just simply take negative 10 times each one of those. Then take your negative in. Like that. Okay? Make those changes. It'll keep you out of trouble. These go away. Negative 20 and a negative 1 makes negative 21. A positive 10 and a negative 42 is a negative 32. Then you can put your remainder, the negative 21x minus 32, all over the divisor of x squared minus 2x plus 1. Okay? And that is the best way to write your answer. But once again, the real trouble areas would be there when people forget to take the negative in on the second part. Okay? So let's try a couple. How about this first one? I have 4x cubed plus 7x. But whoa, there's a missing term here. There's an x squared term missing. It is very, very helpful if you put in 0x squared, then plus 7x plus 9. And we're going to divide by 2x plus 1. Okay? Now, how many times does 2x go into 4x cubed? Think about what you would put up there to take times 2x to get 4x cubed. What you would take times is that 2x squared times 2x is going to give you 4x cubed. So you got to take it times both parts. So I have 4x cubed. 2x squared times 1 is 2x squared. Take the negative in on the bottom. They go away. I get negative 2x squared. Bring down the next term, plus 7x. Okay? How many times does 2x go into negative 2x squared? Whatever you put up there, you got to take times 2x and get that. So I think it's just a negative x. Yeah? Negative x times that is negative 2x squared. Negative x times that. And take the negative in on the bottom. These go away. I have 8x and bring down the plus 9. 2x into 8x should go 4 times because 4 times 2x is 8x. 4 times 1 is 4. Take the negative in on the bottom, and I get a remainder of 5. So put a plus 5 over 2x plus 1. Okay? That's an easy one. Check out this one. Okay. All right, so we got a big one now. We're going to take, and notice we have all kinds of missing terms here. All right, so we're going to do division here. Start up nice and high. So I've got 2x to the 5th, 4x to the 4th, minus 4x cubed, missing term, 0x squared, minus x, minus 3. X squared. Missing term, minus 2. Yeah? Everybody with me on these missing terms? Okay, by the way, our next time together, we're going to be talking about an easier way to do long division. It's called synthetic division, and missing terms are critical. So you want to really be in a good habit here of making sure you put in your missing terms. Okay, so here we go. X squared into 2x to the 5th. What do I put up there to take times x squared to get that? Is it not 2x cubed? Right? 2x cubed times this is 2x to the 5th. 2x cubed times 0 is 0x to the 4th. 2x cubed times this is minus 4x cubed. Take a negative into the bottom. You don't have to put a negative on front of 0, it's still 0. These terms go away, so I have 0x cubed. These is just 4x to the 4th, and those go away. Okay? Bring down your next term, a 0x squared. How many times will x squared go into 4x to the 4th? Whatever you put up there, you have to take times x squared to get 4x to the 4th. So it should be plus 4x squared, yes? 4x squared times x squared is 4x to the 4th. 4x squared times that is 0x cubed. 4x squared times that is negative 8x squared. Take the negative in on the bottom. Okay, these go away. Now, here we have a leading term, which is 0x cubed. And we have 8x squared, and bring down your next term. Okay? X squared into 0x, that's going to be 0x. And 0 times that is all zeros. It's kind of silly to do it, but we get 0x cubed, 0x squared, and 0x. 0 times that is all zeros, okay? These go away. Take your negative in, it's still zeros. So this is 8x squared minus x, and bring down your last term of minus 3. Now, x squared into 8x squared will go just 8 times. 8 times all of this, 8x squared, 0x. 8 times negative 2, negative 16. Take the negative in on the bottom. Don't have to do it to 0. These go out. I get a negative x plus 13. And I'm out of room. So put my negative x plus 13 over the remainder, over the divisor. So I have negative x plus 13 all over x squared minus 2. Okay? Missing terms can be a real pain in the butt. This was an enormous problem. You'll have very few like that, but you should be able to do it. So I've kind of taken section 3 and I've broken it into 2 parts just because the long division can be such a pain in the neck. All right, so you see your homework there, you've got some long division problems on the book problems. And the first problem is one of those parabolas changing to standard form, okay? And everything you're supposed to do with that.